Yeah. So, today I will be starting new chapter, fuels and combustion. So, this is a very important chapter and a very easy chapter also to the examination point, and we need to understand this what exactly it is. Let us understand what you mean by a fuel. Fuel is a substance which releases heat energy when burned at a sufficiently high temperature. The release of sufficient heat energy by burning can take place only if a supply of oxygen is available and combustion is started by a sufficiently high temperature. The atmospheric air is the usual source of oxygen for combustion of fuels. Let us understand this word fuel. It is a substance. It is a substance. So, it releases heat energy when it is burnt, and when it is burned at a sufficiently high temperature, it is going to produce heat and light. So, now here release of sufficient heat energy by burning, it is only possible if oxygen is available. Without oxygen, no fuel burns. It will not catch the fire in the absence of oxygen. So, if you want to burn a fuel, it is necessary for you to supply the oxygen. So, that will be the aid for the combustion. So, then only it will start burning, and which is the one which is going to supply the oxygen. So, that is nothing but atmospheric air. The source of oxygen for the combustion of fuel is atmospheric air. During the combustion of fuel, the fuel will draw the oxygen from the atmospheric air, and it will be taken it as a aid for the combustion of fuel. So, this is the way combustion of fuel takes place, and because of combustion of fuel, it liberates enormous quantity of heat energy, and that is the source of energy. The burning of fuel is one of the most important sources of energy utilized in power plants. All of us are very familiar about the power plants. So, power plants are the one which are used to generate electricity, which converts fuel energy into electrical energy. So, most of the power plant they depend upon burning of fuel. So, that will be the source of energy to generate electrical energy. And other than that, fuels are also used for other industrial purpose, like in blast furnace, in production of iron, it is used as a fuel. So, it not only supplies the heat, but fulfills the important role of reducing as a reducing agent. The burning of fuel is the main source for to generate the electrical energy in power plants. Okay. So, one thing you have to remember, these fuels are always called as hydrocarbon fuels. Why it is called as hydrocarbon fuels? All fuels contain hydrogen and carbon. That is what they are called as, are referred as hydrocarbon fuels. Besides hydrogen and carbon, fuel consists of small amount of other elements such as sulphur, oxygen, nitrogen and ash. So, these are all the constituents of fuel other than hydrogen and carbon. So, the main ingredients are hydrogen and carbon. They are the cause for producing of heat energy. Along with hydrogen and carbon, it consists of sulphur, it consists of oxygen, it consists of nitrogen as well as ash. Okay. So, one thing you have to remember, so this because it consists of hydrogen and carbon in main constituents, that is what it is called as hydrocarbons, or it is also called as hydrocarbon fuels. What are the desired characteristics of fuels? Because whenever you select a particular type of fuel, it should possess some characteristics, because they are those characteristics are very important in generating of huge heat energy. The first point, easy ignition, that means that the kind of fuel you are using it should catch the fire immediately, instantaneously, very easily. So, that is the reason why this is the first important characteristic generally we consider while selecting of fuel. Then second one is high heating value. The heating value is also called as calorific value. What do you mean by high heating value? So, wide varieties of fuels are available, but amount of heat produced by each fuel will differ. The amount of heat produced is based on percentage of carbon and percentage of hydrogen present in the particular kind of fuel. Okay. So, now this is the another important characteristic. The fuel which you are going to select, it should produce high heating value, it should have high heating value, or it should produce high amount of heat or large amount of heat. That heating value is called as calorific value. Then low smoke emission. Today, so we are worried about lot of pollution, right? So, pollutant is nothing but unnecessary ingredient is added to our atmosphere, and most of the fuel will cause lot of pollution. Okay. The kind of fuel which you are going to select, it should have low smoke emission, that means that it has to produce less pollutants because of combustion of fuel. Another important point is easily controllable combustion properties. Here the kind of combustion we can regulate, we can control the combustion. So, now by supplying less fuel or more fuel, if we have control on supply of fuel, we can able to control the kind of combustion, and also we can control the supply of oxygen to the combustion based on the amount of heat we are getting out of the fuel after complete combustion of fuel. Okay. So, now the first point is easy ignition, it should catch the fire very instantaneously, very quickly, easy to get ignited. Then another important point is high heating value, that is nothing but calorific value, it has to have more heating value. That means that when the fuel is burnt, the amount of heat produced after complete combustion, that value is called as what? Heating value. The kind of fuel which you are going to select for the combustion of fuel, so it should emit less emission. So, less smoke has to be produced out of the complete combustion of fuel. Then the combustion can be controllable, that means that can be easily controlled. Next characteristic is low content of impurities. The amount of impurities present in the fuel has to be very low, that means that low ash and sulphur. So, it should contain low ash and it should contain less sulphur. So, these are the main impurities, they will be the pollutants of the particular fuel. So, another important characteristic is they can be stored for a long period without deterioration and are easy to handle, control and transport. This is another important aspect of the characteristics of fuel. That means that it can be stored for long duration of time, so without any deterioration, because the fuel there may be chance of deterioration. So, proper storage has to be there. When proper storage is there, when you are storing the particular fuel for longer period of time, because we need to have reservoir of fuels for the future point of view. So, in that case the fuel should not get deteriorated, it has to preserve its contents, and they are easy to handle. That means that it can be handled very easily and we can control it. So, control of combustion has to be there, otherwise it is very difficult to extract the quantity of the heat coming out of the particular fuel, and it should have, and it should be easily transported from one place to another place. Okay. So, these are all the important characteristics of particular fuel which you are going to select. Then classification of fuels. So, fuels are broadly classified into mainly two types. One is according to the nature of their exist. It is either state or phase. First one is solid fuel, second one is liquid fuel, third one is gaseous fuel. So, according to nature of their exist, so it is nothing but a state. So, it will be solid state, liquid state and gaseous state. So, the fuel are classified into solid fuels, liquid fuels and gaseous fuels. The second classification is according to the nature of their origin, how they origined. So, they are classified into two types. One is natural fuel. The natural fuel is also called as primary fuels, or it is also called as fossil fuels. So, these are the two other names for the natural fuel. That means that the fuel which is available in the nature by itself, then that fuel is called as what? Natural fuel. Artificial fuel, the fuel which is artificially prepared from the natural fuel. This artificial fuel is also called as what? Secondary fuel. It is also called as secondary fuel, or it is called as prepared fuel. Okay. So, this is the two broader classification of fuels. One is according to the nature or state, solid fuel, liquid fuel and gaseous fuel. According to the nature of their origin, it is classified into natural fuel as well as artificial fuel. Okay. The natural fuel is also called as primary fuel, artificial fuel is also called as what? Secondary fuel. The detailed classification of fuel is given below with the example. Okay. Let us see according to the state. They are classified into solid fuel, liquid fuel and gaseous fuel. According to the origin, natural fuels and artificial fuels. Example for natural fuels: wood, it is available in the nature abundantly. Peat, lignite, coal. So, these are the different examples for natural solid fuel. Where in case of charcoal and coke, they are called as prepared fuels. They are prepared from the natural fuel. Next, liquid fuels. The crude oil which is available in the nature by itself. Okay. So, it will be available under the earth crust. Whatever that fuel which is available below the earth crust as in terms of liquid, so that is also called as petroleum, that is nothing but crude oil. And this crude oil is subjected to destructive distillation or fractional distillation to get different kinds of fuels. Okay. So, those fuels are called as artificial fuel or secondary fuel. The example is petrol, we are using it in two-wheelers, diesel, all heavy vehicles will be using diesel, and as well as kerosene. Petrol, diesel, petrol is also called as gasoline, diesel, kerosene, alcohol. So, these are all the different liquid fuels which are produced out of the crude oil, that is what they are called as prepared fuels. Third one is gaseous fuel. So, natural gaseous fuel is natural gas. It is available in the nature at the near the petroleum fields. It will be in the raw form. And artificial fuels are nothing but coal gas, producer gas, coke oven gas, blast furnace gas. These gases are prepared from the either from the solid fuels or from the liquid fuels. Okay. So, this is the major classification and examples for solid, liquid and gaseous fuels as well as natural fuels and artificial fuels. Next, solid fuels. Most solid fuels are obtained by mining. This is what important thing. Most solid fuels are obtained by mining. They burn in solid phase in the presence of oxygen. The solid fuels consist of mainly carbon together with hydrogen, sulphur and some incombustible ash. The example for solid fuels are wood, peat, lignite, bituminous coal, anthracite coal are the examples for solid fuel. So, they are obtained from the mining. They always burn in solid phase and it will be in the presence of oxygen. It will be in the presence of oxygen. It mainly consists of carbon with hydrogen and some constituents are sulphur and also some incombustible ash. What are the examples for solid fuels? Wood, peat, lignite, bituminous coal, anthracite coal are the examples for solid fuels. First example is wood. Wood is used to a considerable extent as a domestic fuel. You have to observe here. It is a domestic fuel. It consists of 50% of carbon. It consists of 50% of carbon, 6% of hydrogen, 43% of oxygen and 1% is ash. These are all the ingredients of wood. The calorific value of dried wood ranges from 10,500 kilojoules per kg to 14,650 kilojoules per kg. It is very cheaply available, but the disadvantage is wood as industrial fuel is a larger moisture content and low calorific value, and it also produces high ash. That means that wood contains larger quantity of moisture. So, because of that reason there will be larger, and that means that there will be insufficient combustion of fuel. That means that large quantity of fuel gets wasted because of incomplete combustion of fuel, and also the amount of heat produced after complete combustion of wood will be very less as compared to the other types of fuel. Next, coal. Coal is formed vegetation in different stages ranging from peat to anthracite. It happens because of vegetation. It happens because of vegetation. Anthracite is the most valuable and peat is the least valuable. The stages of coal formation is summarized as below. You can see here. First is plant debris. The next stage is peat, next stage is lignite, next stage is brown coal, then next stage is bituminous coal, next stage is anthracite coal. This is the different various stages of formation of coal. So, these are the different stages of coal formation. It starts from plant debris to anthracite coal. It is referred as peat to anthracite. This stage formation is called as what? Peat to anthracite formation. Okay. It mainly done with the help of the vegetation. Next is peat. Peat is the first stage in the formation of the coal from wood. So, after wood the first stage is peat. It associated with larger amount of water and it may be as much as 90%. You see a amount of percentage of moisture 90% and only 10% is solid. So, before using it need to be dried at least for 1 to 2 months before using it as a fuel. Its calorific value is 1500 kilojoules per kg and is slightly greater than the wood. During the burning it emits larger quantity of smoke. So, it is not considered as important fuel. Then lignite. Lignite contains high percentage of moisture, that is ranging from 20 to 60%, and it contains small percentage of carbon. It contains small percentage of carbon. They possess low calorific value, and the lignite is the next stage of peat. Next, after first stage is wood, next stage is peat, then it is lignite. The possess low calorific value and lignite is the next stage to peat in coal formation. Lignite with 20% moisture are brown in color. If the lignite contains 20% of the moisture, and that particular lignite color will be in brown and referred as brown coal. Lignite is used for generation of thermal power as well as fertilizer manufacturing, and it also used for making briquettes to be used as a domestic fuel. So, briquette fuel is used as a domestic fuel. The calorific value of that fuel is 21,000 kilojoules per kg. Next, bituminous coal. Bituminous coal contains 70 to 90% of carbon, 20 to 42% of volatile matter and small percentage of moisture. It contains very small percentage of moisture. It represents third stage of coal formation. Peat is the first stage, lignite is the second stage, bituminous coal is the third stage in the coal formation. In peat anthracite series, it forms after lignite, which are used for making metallurgical coke, coal gas, and for domestic heating. The application of that is used for making metallurgical coke, coal gas, and for domestic heating. It burns with long yellow and smoky flames. This burns with long yellow flame and also smoky flames. So, this is about the bituminous coal. Next, anthracite coal. It contains 90 to 98% of carbon. You see here, the percentage of carbon present in this fuel is 90 to 98%, very large quantity of carbon and very little volatile matter, which is less than 8%. It represents the last stage of coal formation. It represents last stage of coal formation. It burns without smoke and with a short non-luminous flame, giving intense local heating. That means that since it contains less volatile matter and less moisture, the amount of heat produced by this fuel will be very high, and it always, whenever less volatile matter and less moisture, obviously there will be less smoke and it will burn with non-luminous flame, giving intense heating. The calorific value of this fuel is 35,000 kilojoules per kg and suitable to use in steam generating units. That means that this is the coal generally preferred in steam power plants to produce in heating water and convert into steam, and that steam will be utilized to produce the electricity in thermal power plants. Next, we will move on to the charcoal. Charcoal or wood charcoal contains about 80% of carbon. You see here, it consists of 80% of carbon and it is obtained by heating or burning wood out of contact with the air. Okay. This charcoal is obtained by heating the wood in the presence of air. Burning of wood in the absence of air referred to as destructive distillation. Burning of wood in the absence of air is referred as destructive distillation. water and various kinds of volatile matters are expelled out of this process. Because of its purity and very low ash content, charcoal is most widely used in as a metallurgical coal. This is about the charcoal. Next, coke. Coke is obtained by heating bituminous coal in the absence of the air. That means that the coal is heated in the absence of the air. The time of heating is about 45 hours at a temperature of 100 degrees centigrade. The process of heating the coal in the absence of the air is called as carbonization of coal. Whenever you are heating the coal in the absence of air, this process is called as carbonization of coal. Coke contains 90% of carbon. You see here the amount of percentage of the carbon, up to 2% is sulphur and small quantities of hydrogen, nitrogen and phosphor. It is mainly used in blast furnace as a fuel as well as reducing agent. It is used as a main fuel in blast furnace. It is a device which is used to produce the iron from the iron ore. Its calorific value is about 29,000 kilojoules per kg. This is about the coke. In certain applications, coal is used in the form of briquettes. Briquettes are prepared from the fine powder of coal or coke by compressing the materials under pressure. That means that the powdered coal is compressed under the pressure. Coal and coke may also be used in the form of fine powder form. Okay. So, this powder, this is powder in the powder form. Coal in a fine powder, this is powder form can be obtained by crushing and is referred as pulverized coal. The powdered coal is called as what? Pulverized coal. Okay. It is, this pulverized coal is nothing but powdered coal. So, the coal is crushed into fine particles. That resulting fuel is called as pulverized coal, and this pulverized coal finds main application in thermal power plants, because if you crush into fine powder and there may be chance of efficient burning of the each and every particle. So, enormous quantity of fuel, enormous quantity of heat is produced. So, after combustion of pulverized coal. Let us study some of the properties of that. The fuel, wood. The amount of percentage of carbon 42.5%, hydrogen is 6.78%, oxygen is 48.62, nitrogen is 0.5, no sulphur and ash is 1.6%. Moisture content is 15%, volatile matter is 80% and higher calorific value is 15,826 and lower calorific value is 14,319. So, later part we will learn about higher calorific value and lower calorific value. Similarly, it is peat. The percentage of moisture is 20%, in lignite it is 15% and in bituminous coal it is 2%, in anthracite coal it is 1%. You see here the amount of carbon, percentage of the carbon, because that is the main ingredient which converts into heat. In peat it is 43.7, in lignite it is 56.52, in bituminous coal it is 81.93 and in anthracite coal it is 90.27. Volatile matter also decreases as the carbon percentage increases, this is decreasing. The calorific value also increases. Okay. 15,826 to 34,583. Okay. So, this is the sum of the chemical analysis of the different types of fuel which are used as a solid fuels. Let us study what are the advantages and limitation of solid fuels. Let us study advantages. These are the some of the following advantages. Solid fuels, as compared to the other fuels, they are very cheaper. Coal is raw material for producing other fuels such as coke, producer gas and water gas. That means that coal is a solid fuel which can be used as a raw material for producing other types of fuels. Risk of fire is minimum. That means that it will not catch the fire instantaneously. What are the limitations of this? It contains maximum quantity of incombustible matter. So, it is the cause for the pollution. It requires large amount of storage space, that means that it occupies more space to store it, hence it requires larger space to store the solid fuels. It produces more ash and smoke as compared to the other types of fuels, and during the combustion it requires more oxygen. The percentage of oxygen required for the combustion of fuel as compared to the other fuel in case of solid fuel is very high. It requires more oxygen for the combustion of fuel. So, these are all the some of the limitations of solid fuels. Next, we will move on to the liquid fuels. We will move on to the liquid fuels. The liquid fuels are obtained from petroleum by distillation. So, below the earth crust, when you drill a bore well into the earth crust, the oil which is coming out will be a crude oil. The crude oil will be in the raw form. It is also called as natural fuel. Petroleum, that is nothing but crude oil, is found under the earth crust. Liquid fuels are also can be obtained from the coal, like coal tar, benzol. They are all the example for liquid fuels. The first example for liquid fuel is petrol, or it is also termed as gasoline. Petrol is the lightest and more volatile liquid. What do you mean by volatile? When you expose petrol to the atmospheric air, it gets easily vaporized. So, it gets vaporized and mixed with the atmospheric air. That is what it is called as volatile liquid fuel. It is mostly used as a fuel for petrol engines. Petrol is preferred in petrol engines, aircraft engines, that is nothing but aviation petrol. We call it as the aviation petrol. Its calorific value is about 46,800 kilojoules per kg. This is the lightest liquid fuel. This is called as lightest liquid fuel. The amount of calorific value it has got is 46,800 kilojoules per kg. Next, kerosene. This is also called as paraffin oil. This is also called as paraffin oil. It is obtained by fractional distillation of crude oil between 140 degree centigrade and 280 degree centigrade. So, the process which is used to separate petrol, kerosene, diesel is destructive distillation or fractional distillation. The natural oil will be heated at different temperatures to obtain different liquid fuels. It is very heavier and volatile than the petrol and is used for illumination as well as heating purpose. The kerosene is preferred for illumination purpose, for lighting purpose as well as heating purpose. It is also used as a fuel in farm tractors, in agriculture fields. So, they use this as a fuel in farm tractors and also jet engines. Its calorific value is 46,470 kilojoules per kg. Diesel oil. Diesel oil may be obtained by straight distillation of several crude oils. So, this is also obtained by fractional distillation of the crude oil. This is used in only diesel engines. Diesel oil is used in diesel engines. The calorific value is very high. It is about 46,000 kilojoules per kg. Next, heavy fuel oil. When you destructive distillation or fractional distillation is applied to the crude oil between 200 degree centigrade to 360 degree centigrade, the fuel oil is obtained. Okay. It is mainly used in steam power plants, heating of furnaces and as well as in diesel engines. Its calorific value is 43,900 kilojoules per kg. So, these are the different kinds of liquid fuels generally we come across. So, let us study the properties of the different liquid fuels. The fuels: gas, petrol, kerosene, diesel oil, heavy fuel oil. their specific gravity you can see here 0.74, 0.79, 0.87, 0.85. According to mass analysis, it contains carbon, hydrogen and sulphur. The percentage of that is, in case of petrol, carbon is 85.4% and hydrogen is 14.6, no sulphur, and the higher calorific value is 46,692 and lower calorific value is 43,710 kilojoules per kg. In case of kerosene, the carbon is 86.3, hydrogen is 13.6, amount of sulphur present in the kerosene is 0.1%. The calorific value is 46,180 and lower calorific value is 43,166. In case of diesel oil, carbon is 86.3%, hydrogen is 12.8% and sulphur is 0.9%. The heating value, that is nothing but higher calorific value is 45,971, lower calorific value is 43,166. For heavy fuel oil, carbon is 86.1, hydrogen is 11.8, the amount of sulphur is more here in this case 2.1, the heating value is 43,961, that is higher calorific value, lower calorific value is 41,366. These are all the characteristics of different kinds of liquid fuels. Let us study advantages and limitations of liquid fuels compared to the other fuels. First, advantages. It has got the following advantages. First one, relatively high calorific value. Compared to the solid fuel, the amount of heating value or the amount of calorific value is quite high as compared to the solid fuels. It burns without leaving a solid residue and with less smoke. That means that the liquid fuels produces less smoke and they do not produce any solid waste or solid residue like